This is the 2009 Impacts and Collisions question. We're going to oblique collision. Smooth sphere A, moving with speed u, and we have a collide stationary identical smooth sphere. Direction of motion of A before impact makes this angle alpha with the line of centers, and they're in the J here, so we're not going to have any change in I. No change in I. And we have E is 4/5. The coefficient of restitution is 4/5. Show alpha is 30. Well, we have a tangent here to the circle, so from the point of the tangent to the center of the circle is a radius, and it's also a right angle. We also have a radius here and a radius here. So if I just take that triangle down here, and I have alpha, opposite alpha is OR, and the hypotenuse is 2OR. So I can say the sine of A is opposite OR over 2OR, which is equal to 1/2. And the inverse sine of 1/2 is equal to 30 degrees. Therefore A is 30, alpha is 30. Find the direction in which each sphere travels after collision. So we write down our vector, it's going to be u, and because it's along the J line, it's going to be u sine alpha. So u sine alpha in the I direction, plus u cos alpha in the J direction. So this is before, so it's going to be u over 2, alpha is 30 in the I, plus root 3 u over 2 in the J. So this is A before, and B is at rest. 0I plus 0J. We have u over 2I plus root 3/2 in the J. What are their masses? M, identical, M. So no change in I, so we're going to have u over 2 in the I plus P in the J. And we're going to have 0 in the I plus Q in the J. So we set up our equations. We're going to have M by root 3, I left out my u here, u over 2 plus M times 0 is equal to M times P plus M times Q. So P plus Q is equal to root 3u over 2. We also have P minus Q over root 3/2 minus 0. We have coefficient restitution is 4/5. So that's going to be equal to minus 4/5 times this root 3u over 2. So we're going to get 10p minus 10q is equal to minus 4 root 3u. From down below we have 10p plus 10q is equal to 10 root 3u over 2, so that would be 5 root 3u. So we're going to get 20p is equal to just root 3u. So p is equal to root 3u over 20. Q, do we have an equation for Q? Q is equal to root 3u over 2 minus p. So Q is equal to, that would be 10 root 3u over 20 minus p, which is just 1 root 3u over 20. So Q is equal to 19. No, 10 over 20 minus 1, 9. 9 root 3u over 20. So that's Q. And this one up here, P. So we write our vectors out again. A is going to be u over 2. A u over 2 in the I direction plus root 3u over 20 in the J. B will be equal to 0 in the I plus 9 root 3u over 20 in the J. And the inverse tan will give me the angle. is the inverse tan of root 3u over 20 divided by u over 2, so multiplied by 2 over u is going to be root 3 over 10. The inverse tan of this, and on the other side we're going to have the inverse tan of 0. It's going to be undefined, so this one's along the j-axis or along the line of centers, and the inverse tan of root 3 over 10. So the inverse tan of root 3 over 10 is, I think it works out to be 9.8 degrees. Just double check that, 9.8 degrees. So not a massive deflection. Then the percentage loss in kinetic energy due to the collision. So the percentage loss in kinetic energy, let's look at half mv squared for both. So for A, half m. So it's just a half m, and where we were told the speed was u, weren't we? Speed u. So we can just take u as the speed at the beginning, a half mu squared for the speed at the beginning. And then afterwards we have A. It's going to be a half m by the square root of, obviously, u squared over 4, u over 2 to be squared, plus p to be squared, which is, what do we get for p? It's root 3 u over 20, so 3u squared over 400. So that's going to be 100u squared over 400, it's 103u squared over 400. Times a half m. And then for b, it's going to be a half m times just q squared, which is going to be this guy plus this guy both to be squared. So it's going to be, no, it was the 19, wasn't it? We got 19 or 9, so it's this guy squared. So that's 81 by 3, 243 u squared over 400, 243 u squared over 400. So these two added together is going to be 346 u squared over 400. And it started as a whole u squared over 400, if we imagine. So the loss in kinetic energy is going to be, what is it, 54 u squared over 400, 27 u squared over 200, it looks like. As a percentage, so this would be 13.5 u squared over 200, so, or 100, so that's 13.5% loss in kinetic energy.